Good morning and welcome to Computer Science 311, Data Structures and Algorithms. Today we are going to do the last of our advanced sorts. So far we've already done heap and we've done merge. So this is heap sort, merge sort. And today we do another cool one, and it's called QuickSort. And remember, the feature that makes all of these the advanced sorts, these are all big O of n is equal to n log n. And again, when we do QuickSort, we'll have to analyze it and prove that that's the case. QuickSort is based on a fairly simple idea, and it is going to employ some recursion here. But let's imagine that we have an array that looks like the following: 33, 56, 9, 87, 4, 62, and again, I'm just making these numbers up: 73, 3, 5, 42. So this is what the array looks like. We have indexes here: 0, 1, 2, 3, 4, 8, 9. I'm going to do a couple of things over here. I'm going to call this array AR. So I'm going to come over here and I am going to have something that I'm going to call the pivot value. And we'll talk about that a little more later. But I'm going to let it be the leftmost element in the array. So it's going to be AR of 0. And I'm going to have something called my left pointer. And I'll let that be 1. And I'm going to have something called my R pointer, my right pointer, and I'm going to let that be 9. So I'm basically pointing over here, and I'm pointing over here. And basically, I'm going to do something like the following. I'm going to say, while AR of L pointer is less than pivot, I want to do L pointer plus plus. So in other words, while this is pointing at something that's less than the pivot value, move this pointer forward. Now we can see in this case that's not the case, but then what I'm going to do on the other side, I'm going to say while AR of R pointer, I want to make this less than or equal. Over here I'm going to say while AR of R pointer is greater than the pivot, what I want to do is R pointer minus minus. So this is going to stay here. I execute this first, and this is already greater than that. It stays there. I'm going to come over here, and I'm going, well, this is greater than the pivot value. So what I am going to do is advance the pointer to the left. So now here's R pointer. I'll just put an R here. Here's an L here. And now what I want to do is I want to swap these two. Okay, I'm going to move this one over to here. I'm going to move this one over to here. But I'm even going to do a little bit more. What I'm going to do is after I do the swap, I'm going to advance the L pointer by 1, and I'm going to decrement the R pointer by 1. So the idea is that ultimately over here is going to be 5. Well, I guess I can make 56 into a 5 just by doing that. And I'm going to advance the L pointer to here. This is going to become 56, and I will decrement the R pointer to here. And now I'm going to loop around again, and I'm going to repeat this stuff. So now this is less than the pivot, so I'm going to advance L pointer. And it's going to stop there because that's greater than the pivot. And over here, what I'm going to do is it doesn't advance at all because that's already less than the pivot. So now what I'm going to do is I'm going to swap the 87 and the 3. So I've got a 3 over here, and I've got an 87 over here. And remember, at the very same time, what I want to do is I want to advance this now to the next one, and I want to lower this by 1. So now, this is pointing at the 4, and this is now pointing at the 73. And I'm going to go around again. And what's going to happen is this is less than the pivot, so I'm going to advance the L pointer. And now it's over to here, and it's going to stop. And now I'm going to come over and look at the right pointer, and we can see that the right pointer is not only going to come over to here, but it's going to come over to here. So in fact, now the pointers have crossed. Okay? Well, I want you to notice something about what this array looks like now. Let me get this out of the way. And let's come over here. I'm going to put this right underneath it. Because I want you to notice that everything over here we know by definition all of this is less than or equal to 33. And we know that everything from over here, we know that this is greater than 33. Oh, and by the way, we have the number 33 over here. So I'm going to do one more thing before I'm done. What I'm going to do is I'm going to swap this 33 with whatever number is over here. And then I have the following situation. I know everything here is less than or equal to 33. I know that over here is the number 33. And then I know that everything over here is greater than 33. Well, I think you can see what I'm going to do now and where the recursion comes in. I am now going to I'm going to repeat this same algorithm all over again on this side over here and on this side over here. Pretty cool. Okay? So what I want to do is I want to broaden this. I want to write all the code for this out. And my first attempt at this is going to look something like the following. Well, we'll notice that what eventually happened is that the right pointer crossed over the left pointer. So what I want to do over here is I want to say something like the following. While the left pointer is actually less than or equal to the right pointer, what I want to do in here is I now want to do this code over here. So I want to say while AR of left pointer is less than pivot, L pointer plus plus. And then I want to say while AR of right pointer, I'm going to make this less than or equal. Well, that's greater than pivot. Then what I want to do is R pointer minus minus. Now what I want to do is I want to go here and do a swap, but it may be the case that these guys actually crossed each other. So I want to come over here and I just want to check the following. I want to say if L pointer is less than R pointer. So you might be wondering, why don't I say less than or equal? Well, if they're equal, I don't care. Then there's nothing to do. So I just want to say if left pointer is actually less than right pointer, what I want to do is the following. Temp equals AR of L pointer. AR of L pointer equals AR of R pointer. AR of right pointer equals temp. I'm going to move this up a little bit. And then what I want to do is I want to do my left pointer plus plus, and I want to do my R pointer minus minus. I'm going to close that up, and I'm going to close that up. Okay, so I've got some code here, and I want to check it. I have all sorts of things that I worry about here. Okay, so I consider one case here. Suppose I've got a 30 here, and I've got a 3, 40, 5, 60, 6, 70. There's my pivot. There's my left pointer. There's my right pointer. While left pointer is less than right pointer, while AR of left pointer is less than pivot. So I'm going to come over here, and here is my left pointer now. So it's over to here. That's L. While right pointer is greater, so that's fine, and it's going to move over. So here's R. Okay, I go if left pointer is less than right pointer, swap these guys. I'm going to go ahead and swap. So what's going to happen over here is this is going to be a 6 and this is going to be a 40. And what's going to happen now is I advance these pointers. So I now look like this. Okay, I now go to the top of the loop. Left is less than right, so I go while AR of left pointer is less than pivot, left pointer plus plus, so left pointer is going to advance. So the left pointer is now pointing over there. While AR of right pointer is greater than pivot, we're going to decrement it. So now this is pointing over here. Okay, if left pointer is less than right pointer, it isn't. So we're all done with this. Oh, and by the way, the thing that we know that we want to do over here is once I get out of here, remember we said that what we want to do, I wish I had more room, down here, what I want to do is I actually want to swap. So I want to say something like temp is equal to AR of right pointer. And then I want to say AR of right pointer is equal to AR of 0, and AR of 0 is equal to temp. Remember what that's done now is I've now come over here and I've put the 5 over to here, and I've put a 30 over here. So this is 30, this is 5. And then what I want to do is I want to do a quick sort. Remember, this is a recursive thing. okay, from 0, and I'm going to specify a couple of things over here. I'm going to do a QuickSort on the left side, so that's going to go from 0 all the way up to our pointer. Or no, I'm sorry, remember, because what we've done now is we have these 3, we have 30, so remember our pointer is here, L pointer is here. So we want to do a QuickSort from 0 to R pointer minus 1. And then we also want to do a QuickSort from L pointer to the end of the array. 0, 1, 2, 3, 4, 5, 6, like this. Okay. What we of course need to do up here is we need a base condition, which is that if the left side and the right side are equal, then we're all done because we just have an array of 1. But so far, I'm happy with this code. But you should all know me by now. I'm never happy with the code. There are what are called the corner cases. So let's look at this code over here, and I want to consider a different situation. Suppose I come in here, and I've got the number 30 here. That's my pivot. And suppose I've got 1, 2, 3, 4, 5. Suppose I'm very unlucky and I pick a pivot that is actually greater than all of these. So here is my left pointer. And over here is my R pointer. And here's the problem I have. Over here, I'm going to go while left pointer is less than right pointer. So far, so good. Then I come in here, while AR of left pointer is less than pivot, I'm going to keep advancing this. Well, if I keep advancing this, a couple of things are going to happen. First of all, yeah, the pointers are going to cross each other, but I could potentially, because L pointer is going to get all the way up to this index over here. The indexes are 0, 1, 2, 3, 4, 5. L pointer is going to get all the way up to 6, and I might throw an exception over here. So what I need to do is I need to guard off going off the end this way, and I think you can see what the other problem is going to be. If I were to have a 30 here, and this was 60, 70, 80, 90, 100, and here's my L pointer, and here's my R pointer, what's going to happen is this would get the R pointer, this guy would sit right here, and the R pointer would come all the way down to here. Well, that's not going to give me a subscript error like this one is over here. But I think what we need to do is we need to guard against these things. So first of all, let's think about this. It seems to me that QuickSort is going to be coming in with 2 parameters, a left endpoint and a right endpoint. So I think what we need to do is we need to do something like the following. Maybe we need to say public void QuickSort. And I'm going to come over here and I'm going to say left end. Oh, that should be an int. And then int right end. Okay. And I'm going to come over here and I'm going to say the following. I don't know, I might need to leave some space here for some variables, but I'm going to say if length end equal right end, return. Okay. Otherwise, what I want to do over here is I want to come over here and I want to say int pivot is equal to, I guess I need one more parameter here. The array. Let's not forget the array. comma, int AR. So I'm going to come over here and I'm going to say let the pivot be AR of left end. I'm going to come over here and I'm going to say int L pointer equals left end plus 1. I'm going to come over here and I'm going to say int R pointer equals right end. Okay, now we can see, let's, I'm going to get rid of this again and let's go back to some of the problem things that we had here. Well, we said over here, okay, that left pointer could go all the way off the end. In other words, we may get the situation where L pointer is actually greater than right end. So I think what I need to do is I need to guard for that over here. In other words, what I need to do is I need to guard against L pointer getting greater than right end. And likewise, what I need to do over here is I need to guard against the R pointer equal to left end. Okay, so what I'm going to do over here is first of all, this is still going to stay the same, and I'm going to say while the L pointer is less than or equal to the R pointer. And now I've got to come in here and I've got to put these guards in there. And I'm going to take advantage of Java short circuit computation. What I'm going to do is I'm going to check this condition before I check that condition. So I'm going to say while L pointer is less than or equal to right end, and AR of L pointer is less than or equal to pivot. And here's where I'm going to do my L pointer plus plus. Likewise, I'm going to come over here and I'm going to say while R pointer is actually greater than left end, and AR of R pointer is greater than pivot, I'm going to come over here and I'm going to do an R pointer minus minus. Okay, and now what I'm going to do, and I'm running out of space here, I do apologize. Okay, what I do over here, this is down here. It's going to be up here. And this is basically my swap. If L pointer is less than R pointer, then what I want to do is temp is equal to AR of L pointer Okay, so there I've done the swap. I want to advance this pointer. I want to move this pointer to the left. Like that. So that is the end of that. And then over here, this is the end of while L pointer is less than or equal to R pointer. Okay, now at this point, remember what I want to do is I want to say temp is equal to AR of left end, AR of left end is equal to AR of R pointer and AR of right pointer is equal to temp. And here I'm going to say swap pivot. And now I make the recursive call. I come over here and I say QuickSort. From left end to R pointer. Okay, and then I do QuickSort. Oh no, this is a mistake. This would be R pointer. It's a little mistake. R pointer -1, because remember in R pointer we actually have the pivot. And then over here we would do QuickSort from L pointer to right end. And that's it. So the analysis of this, okay, there are a couple of things to think about here. But the analysis of this is sort of similar to the ones that we've seen before. We go over all the elements, okay, and there are n elements, and the question is how many times do we do it? Well, this all has to do with the pivot. If every time I pick the pivot, it actually cuts the array in half, we know that we're going to be cutting the array in half a total of log n times. And for each one of those times, I'm looking at all n elements. So in the best case, I'm going to get n log n, and that's when the pivot splits all arrays in half. But I could have a really, really, really bad situation. The bad situation would be is when the pivot's an endpoint. In other words, I pick a pivot and it's the smallest element in the array. So basically what I've done is I pick a pivot over here, okay, and maybe this is less than everything else. So now what I have to do is I now have to make a call on all of that. So I come over here and I've got a call on all of that, and who knows, maybe this pivot is less than all of these. So I make the recursive call there, and now what happens is I'm like this, and again, maybe the smallest element is over here. So you can see that what's happening over here is here I've had to look at n-1 elements, and here I've had to look at n-2 elements, and here I've had to look at n-3 elements, and it goes all the way down to one element. So that the complexity here is going to be 1 plus 2 plus 3 plus all the way up to n-1. And we know that that's equal to n-1 times n over 2, okay? And that would say that big O of n is equal to n squared. So in the worst case scenario, the complexity of this thing is n squared. And that's if you're always picking a pivot that's always either the smallest in the array or the largest in the array. So there has been a lot of research in here about how can you avoid that. So the idea is pick the optimal pivot. Well, but that's a problem. If I always want to pick the pivot that's right in the middle, The problem with that is the only way that we know to find the middle value would be to actually sort the array. So this is, I'm going to say here we would have to sort the array. Okay, won't work. Or I'll say no advantage. So here's another proposal that people have had. People have said, when you want to pick the pivot, come over here, and instead of taking the leftmost element, look at the leftmost 3 and pick the median value. And pick the median value to be the pivot. So in other words, if you pick the median value, then at least what you're hoping, unless they're all the same or 2 of them are the same, is that you've picked a number where you know there's at least one less than it, and you know that there's at least one greater than it. That's a better way. And like I said, there have been many interesting research papers that have focused on this idea of how to pick it. But that's it. We're all done. QuickSort. Kind of neat. Okay? Code it up, kids. See you later.